So this compound, which is P, firstly you're gonna have to look at the chemical equation, and you can see that the formula for the compound indicates that it's a haloalkane. So you have compound P, which is a haloalkane. It's gonna get diluted with sodium hydroxide, forming 2-methyl-butan-1-ol. So it's gonna form an alcohol from the haloalkane, and it's gonna be added with concentrated sodium hydroxide, which is gonna give us compound Q. Then compound Q is reacted with hydrogen bromine to give you compound R as a major product. So now the first thing they say, name the type of reaction represented by 1. So what I'm gonna do here is that you're gonna have a haloalkane and you're gonna dilute it into an alcohol. So if you look at it, this OH is gonna replace your bromine. So since it's gonna replace it, you can say bromine has been substituted by the hydroxyl group. So that's why they say it's a substitution reaction, because this bromine is gonna go out and the hydroxyl group is gonna go in. So I'm pretty you understand that part, why they say it's a substitution reaction.
Yes, sir.
Okay, let me just increase my volume. So now they say it's 2-methyl-but-1-ol, butan-1-ol, a primary, secondary, or tertiary alcohol. So there's a way to find this. So if you just look at it, they say butan-1, meaning that the OH group is attached to the first carbon on the butanol chain. So if it's only attached to the first carbon, that means it's not attached to any other carbon other than the first carbon. So that's going to be a primary alcohol, because it's going to be attached to one carbon and not 2 or 3 more carbons. Basically, if you want, you can just draw it, because it's going to be something like 1, 2, 3, 4. Then here you're going to have your methyl group. This one, you're going to have your OH group. So if you look at it, the first carbon is only attached to one other carbon. if this was here, then it would be attached to 1, 2, 3 more carbons. It would be a tertiary alcohol. But since it's only attached to 1 carbon, it's gonna be a primary alcohol. I'm sure you understand that part. So do you understand that part?
Yes, sir.
Okay. So that's why they say it's a primary alcohol. So now we're gonna go to the next question. So they say write down the structural formula of compound P. So for compound P, you have 5 carbon atoms. Oh, 1, 2, 3, 4, 5. Oh yeah, I'm sorry. So since you know that this has 1 methyl group, and that methyl group is on carbon number 2, so you can just, you don't have to, so you know that it has a methyl group on carbon number 2, so you're gonna have this here. That's gonna be your fifth carbon. Then the bromine, it's on carbon number 1, so you're gonna have Br here. Then the rest is just gonna be hydrogens. One, two, three. So the rest is just gonna be, here there's gonna be 3 hydrogens, here there's gonna be 2, 1, 3 plus 2, that's 5, 6, and here that's another 5, making it 11. So I'm pretty sure the structural formula is not that hard, because they actually want to trick you, because here they say C5H11Br, but here they tell you that there's a methyl group. So you have to know that you have to indicate the methyl, that there's a methyl group, and that's where your fifth carbon is found. So do you understand this part? Sorry? Do you understand this part?
Yes, I understand, sir.
Okay. Because I just want to make sure that you understand. As I said, I'm gonna be writing on Monday, so I don't know. You said you only don't understand chemistry, so does that mean like on Monday, on Tuesday, we're not gonna do physics, we're just gonna continue with chemistry?
Yes, sir.
Okay. So they say name the type of reaction represented by Roman figure 2. Let me rub this out. So if you remember, most of the time when they use something that is concentrated, they're gonna eliminate. But when they use something that's dilute, they're substituting. So in this particular case, they're using a concentrated base. So that means they're gonna eliminate the bromine. And when they're using the same base, but it's diluted, they're gonna substitute. So basically, the reaction two, it's an elimination reaction or dehydrohalogenation. Basically, when you're dehydrohalogenating something, that means you're gonna remove the halogen. You're gonna remove the halogen group from the reaction. So does that make sense? I'm sorry. Does that make sense?
Yes, makes sense, sir.
Yeah. So basically, when they use something that's concentrated, no, it's elimination, and when they use a dilute acid or base, know that it's substitution. So if you're gonna remove the halogen from compound P, that means you're gonna replace the halogen group with the hydrogen. So instead of having this is now gonna be a hydrogen. And that bromine is no longer gonna be there. So they say to which homologous series does compound Q belong to? So if you look at this, but now since it'll no longer have the bromine, it changed from a haloalkane to an alkane. Oh yeah, sorry, to an alkene. Sorry. Oh yeah, I'm sorry. Oh yeah, sorry. I think I got it wrong when I was explaining to you. So basically, since this is an elimination reaction, so that's not gonna be there. It won't be replaced. If it's replaced, it's substitution. Sorry about that. So basically, that means this will no longer be there. And here, a double bond will be formed. And this hydrogen will also no longer be there. That's why it's dehydrohalogenation. You remove a hydrogen and a halogen. So is that fine? Sorry about that. Sorry about that
Yes, sir.
mistake. I mean, okay,
It's fine. I understand now, sir.
okay. So they say name the type of reaction represented by reaction 3. So basically, you eliminated the bromine group, and now you have an alkene. And when you add a hydrohalogen to an alkene, I'm sorry, when you react a hydrohalogen with an alkene, this bond is gonna be broken, and basically it's gonna change back into P, and that's gonna be and that means that you added. So it's gonna be an addition reaction now. But this time it's not gonna go directly to the first carbon. Since like there was a double bond, when this double bond breaks, it's not gonna go directly to the first carbon. It's gonna go to the second one here. And here there's gonna be a hydrogen, but this one is gonna be your bromine group. Do you understand? Do you understand that part? I'm sorry, do you understand it? Or should I explain why it goes there instead of the first one?
Can you please explain, sir?
So if you remember, when you're adding, it's gonna go to the to the most stable carbon in a way. So this one, it only has 2 hydrogens. And this one, oh yeah, it's gonna go to the carbon with the least amount of hydrogens. I'm sorry. So you understand it now? Because when this and this is eliminated, this is stuck with 2 hydrogens. And now this one has no hydrogens. So it's gonna go to the carbon with the least hydrogens. So it's gonna be here. So basically the halogen is gonna go to the carbon with the least amount of hydrogens. Then the hydrogen is gonna go here. So they understand why.
Yes, sir.
Yeah. So now they say the type of reaction that occurs in 3, that's addition. Write down the UPEC name of compound R. That's gonna be 2-bromo, 2-methyl butane. I'm sure you understand why, because now the bromine is gonna be here and the hydrogen is gonna be here. That's why it's gonna be 2-bromo, 2-methyl butane. So far, are you still fine?
Yes, sir.
Okay. So now they say 1,2-dibromopropane can be prepared from butane 2-ene by a 3-step process as shown in the diagram below. Butane 2-ene gives you compound A, gives you compound B, gives you 1,2-dibromopropane. So they say using condensed structural formula, write down a balanced chemical equation for step 1 and indicate the reaction conditions with an arrow. So in this particular case, that's why like most of the time I don't really teach organic compounds, because it requires a lot of self-study. Because right now I can give you the answers, you can go check through the memo, but if you don't know how these reactions occur, it's not gonna be useful to you. So basically, that's why I keep suggesting, like, when it comes to organic compounds, you should do a lot of self-study. I will be able to help you with the other ones, but when it comes to organic compounds, it requires a lot of self-study. So basically, what's gonna happen is that you're gonna change butane 2-ene to from an alkene to an alkane. So this is the formula for butane 2-ene. So they want the condensed structure formulas, but I'm gonna give you the structural. I'm gonna use the structural formulas to illustrate. So you're gonna have 1 carbon, 2 carbon, and you're gonna have a double bond here to your 3rd carbon. So hydrogen, 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 another hydrogen, 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 hydrogen. So in order to convert this from an alkene to an alkane, you're gonna need to add 2 hydrogen atoms. So when you add these 2 hydrogen atoms, this bond is gonna be broken, and you no longer have a double bond. You're gonna have a single bond like this. But there's a catalyst required for the reaction to occur. And in this particular case, the catalyst is most likely gonna be platinum. Like most of the time, they're just gonna use platinum. It's platinum, yeah. It's usually platinum. So whenever you see an alkene being converted to an alkane, your catalyst is platinum, and you're adding 2 hydrogen atoms. But I gave you the structural formula. The condensed version is here on the memo. So you say write down the type of reaction in step 2. So since now we converted butane 2-ene to butane, you're gonna have to crack it so it doesn't have 4 carbon atoms. It has 3 now, because they want butane 2-ene to propane to 1,2 dibromopropane. So basically, what's happening is that you can either say you're eliminating or you're cracking, because what's gonna happen is that you're gonna have your butane. Oh yeah, I'm sorry. Let me just write it in this form. So that's gonna be C4H. So that's gonna be 8 plus 2. That's gonna be split into C3. This is H8. Sorry, do you remember how many carbons butane has? Sorry, how many hydrogens butane has? Because I think it's 10, but I'm not sure. Okay, let me just 3, that's 6, 4. Yeah, that's gonna be 10. So basically, this is what's gonna happen. You eliminate. You can either say you eliminated a carbon and 2 hydrogen atoms, or you can say you cracked butane into propane and CH2. So this is gonna be probably gonna be 2 minus or something like that. But you understand, right?
Yes, sir.
Okay.
So does butane have 8 or 10?
It has 10 hydrogens. Propane has 8 because the formula was the general formula. I think it's CnH2n plus 2. So butane, you're gonna have 4 here. 2 times 4, that's gonna be 8. 8 add 2, that's gonna be 10 hydrogens. So it has 10 and propane has 8. So now we can go on to write down the UPEC name of compound B. So what happened here was that what happened was that instead of it being cracked into, so it's going to be C4H10. So instead of it being cracked into propane, because I forgot that we're gonna have to add Br2. I'm sorry, dibromine into it. So that means it's gonna be converted to C, and that's gonna be 6. It's gonna be H6, and you're gonna have methane. Because you're gonna have to add dibromine to this in order for it to become 1,2-dibromopropane. So basically, me saying that there was gonna be CH2 left was wrong, but you're gonna have methane left. Do you understand that part? Because basically what happened is that I looked at the previous equation, but I didn't look for the forward one. So